Hello and welcome to the sunscreen problem. What I'd like you to do right off the bat here is just pause the video and everybody copy down this chart, this table. And then I want you to fill it in according to the information here. There's 505 teens by the American Academy of Dermatology. Everybody loves dermatology. I know I did in high school. It includes 254 boys, I'll kind of highlight this, and 251 girls. 33% of the boys said they wear sunscreen, and 53% of the girls said they wear sunscreen. So your first task is to go ahead and see if you can fill in this table and get these right. Once that's done, then restart the video and check your answers. So pause it now. Okay, and play. When you do the calculations, it should end up looking like this. 217 wear sunscreen. There are 254 total boys. There's 251 total girls. So this is what should be filled in here. Okay? So now pause the video again, and let's try to answer each of these questions here in part B. Once we have this kind of set here. Answer each of these. Pause the video now. And play. Okay, the probability that someone wears sunscreen, now we're looking at all the sunscreen wearers. There are 217 of them out of the total number of people, which is 505. Just kind of draw where my answer is. The probability that someone is a boy, we can just leave this as a fraction, by the way. The probability that we choose somebody at random and the probability that that person is a boy would be the boys, 254, out of the total 505. Those aren't too bad. Now this is where it gets interesting. Find the probability of somebody that wears sunscreen and is a boy. So now out of these 505 people, we're going to reach and select somebody and see, I wonder if this person, what's the probability that they're going to be a boy who also wears sunscreen? So there's 505 total, and how many boys wear sunscreen? 84. So this is 84 out of 505 is the answer here. Okay, the probability that somebody wears sunscreen or is a boy, though, that's a little different. Now we're looking out of all these people, what's the probability that either they say, yeah, I wear sunscreen, or they say, yeah, I'm a boy. So what I would do here is I'd say, all right, let's look at all the boys. Here's 254. Let me come over here. 254 boys, plus the people that wear sunscreen. Those, here's the sunscreen. There's 217 of those. But if you notice, I double counted these 84. I counted them with the boys, and I counted them with the sunscreen. So we don't want to double count those. Let's subtract that. And this is out of the total. And I think this answers 387. Yes, so this is 387 out of 505. And that is the answer to this one here. The next one is a conditional probability. What's the probability he wears sunscreen given he's a boy? So first of all, we're looking at the group of the boys. Just looking out of these 254 boys, what's the probability that one of those boys wears sunscreen? That's 84 out of 254. And the last one, what's the probability that he's a boy if he wears sunscreen? So first you know this. The sunscreen group is these 217. And 84 of those are boys. So here's our answer there. Okay? Go ahead and pause the video now and answer the question about if you think being a boy and wearing sunscreen are independent events. Pause. And play. There are 3 different ways you could prove this. Here are the 3 different formulas. I'll show you each of these 3 ways that you could have done it and gotten full credit if this was a quiz. This is probability of A and B equals A times B. This is one way to prove independence. What's the probability that somebody is a boy and wears sunscreen? We already did that right here. 84 out of 505. And the probability, we want to see, does this equal the probability of being a boy We got that, 254 over 505 times probability of wearing sunscreen, which was 217 out of 505. Let's see if these equal each other. I'll just go to the calculator. 84 divided by 505, 0.166. 254 divided by 505, I get 0.502. 217 divided by 505, I get 0.429. So if I multiply these two together, that gives me 0.215, and that does not equal 0.166. So therefore, not independent. Another way I could have proven this is I could say, okay, the boy, we have that. That is 254 out of 505, and we just did that as 0.502. Does that equal the boy given sunscreen? We have that answer over here. Boy given sunscreen, 84 over 217. If I divide that, that is 0.387. And again, not equal to, again, not independent. Lastly, I could have done sunscreen. Where's sunscreen? That was this, 217 out of 505. I think I have that up here. Yep, 0.429. Does that equal the conditional probability of sunscreen given a boy? We did that one here. That was 84 out of 254. Punch that up, 0.33, not equal to, so again, not independent. 3 ways you could have gotten this answer right, but I'd be looking to see this kind of an equation set up and then the numbers to follow.